All right, folks, we are going to learn the fire drill formula. So pretend like Murray has a fire drill and you, instead of lining up by last name, people line up by height. And then we say, wait, something really goofy is happening in the admissions department because the height of everybody is exactly, let's say, half a centimeter taller than the person right next to them. So their heights are increasing at a uniform rate. So pretend like there's 8 people here. 1, 2, 3, 4, 5, 6, 7. Okay. If we wanted to find the average height, we could clearly add up all 8 heights and divide by 8. But see if you can think about what would be the lazy, clever, and attractive way to calculate the average height of those 8 people. Okay, awesome. You could average the height of the tallest and the shortest, or the next tallest and the next shortest, or the next tallest and the next shortest, or the middle 2 people. And if it was not a number of people, you could find the person in the middle and they have the average height. Again, only going to be true if the heights of the people are increasing at a uniform rate, right? Because if you had a whole bunch of really tall people and then one kindergartner, you could not take the tallest and the shortest and divide by their and average those 2 heights. Okay, so that is my way of convincing you that this formula makes sense. The fire drill formula, clearly Miss Groppy's goofy name for it, but the fire drill formula is the bar over the velocity means average. If the velocity is linear, which we saw it was in the lab, right? If the velocity is increasing or decreasing at a uniform rate, the average velocity in any time interval. So your speed time has to pass in order for the speed to change, right? So the average velocity between T1 and T2 is the velocity at the beginning of that interval plus the velocity at the end of that interval divided by 2. Be really careful because the average acceleration is v final minus v initial over t, right? So it's real easy to confuse these 2 equations because they're both fractions and they both have 2 velocities in the numerator. All right, you will get this formula. Please write it down, and we're going to practice it, and hopefully this will be a quick video. Okay, again, this formula only works if your speedometer dial is changing at a uniform rate. And then we are going to use that formula that I call the fire drill formula in conjunction with a different position function where I'm going to call this don't know, don't care about acceleration. And you'll see why when we do the example problem. So my position is I have to correct for a head start if I have one. Often this is 0 plus, and I think it's just more efficient if I just give you the formula like this from the get-go. But I'm happy to give you both if people have preferences. Okay, so this is a different position function because if you notice, if you don't know the acceleration, and again, I'll show you a problem in 2 seconds. If you don't know the acceleration, but you know the car went from 0 to 60 at a uniform rate, I don't want to take the time to find the acceleration. I could, but I don't want to. If you want one-stop shopping and not a 2-step problem, then you use this because I don't care about the acceleration. Don't care, don't know, but I do know my initial and final speeds. This is finding the answer in 1 step. Okay, so please write this formula down as well. All right, let's see how this works. A car goes from 0 to 60 in 3 seconds, and we want the distance traveled by the car in this time. So practice your formula, and then we'll compare notes. All right, so this is the don't care about acceleration position formula. We did not have a head start. We just want the distance traveled from where it started, so that's 0. We went from 0 to 60, so the average velocity is 30. You can see it doesn't matter whether you did 60 plus 0 or 0 plus 60, and it did that for 3 seconds. And you can see that the seconds cancel, leaving your final distance as 90 meters. So that's how far the car went. Okay, we're going to check our work, and then we're done. So you're going to confirm your answer by calculating the acceleration of the car, and then you're going to use the initial position function to determine the distance traveled. So we're going to do it in 2 steps. First, find the acceleration of the car, and then we'll compare answers. All right, so the velocity function is v equals v naught plus at. My final speed was 60. My initial speed was 0. I did that in 3 seconds. Divided both sides by 3, and then just kind of flipped it around because we cared about a. So the acceleration is 20 meters per second squared. And now use your position function to figure out how far it went. Okay, position function had a bunch of zeros, didn't have a head start in location, wasn't moving at the beginning, so all of the motion was caused by this acceleration. Time squared over 2, so you got 0 plus 20 over 2 is 10, times 3 squared is 9. 90 meters, yay. So what's nice about these equations is there's often more than one way to do the problem. So first of all, if you're comparing your answers with mine and I did it a different way, but we get the same answer, you're probably right. And then B, if you have time on a test, you can check your work by solving a problem using 2 different methods. Okay, that is the fire drill formula. That is hopefully one of the easier equations to use because nothing is squared. So thank you for listening, and I will see you in class.